Hello everybody, glad to see you. Today we are going to implement GD&T for this component. As we have talked in last session, this component is in contact with this yellow component, this green component. It is in contact with this yellow component by having this M8 bolt. The same as always, we are going to have these datum references. This area is in contact. Let us call it reference plane A. For now, let us consider this datum axis B here as a secondary datum reference. And then in order to fix the coordinate system, we are going to consider this datum axis C here, as we can see here. In second step, we need to qualify these datum references. For A, we are going to consider flatness 0.1. We have talked about this value. 0.1 is applicable. We have talked about that in last session. For datum axis B, let us consider this circularity 0.3 and it should be perpendicular to A with TZ of 1. We are going to qualify B as well. For datum axis C, it is just for fixing coordinate system. We are not going to qualify it. Just it is for fixing. Now let us talk about these 8 holes here. We have calculated the total TZ is 2, and for the hole, the TZ should be 1. Case 1 is a straightforward. We are going to have, let's say, positioning and orientation. This TZ is 1 here, we can see in case 1, respect to ABC, and it should be perpendicular to A with a TZ of 0.1. As we have talked, we can have this 0 MMC, and we can have this dynamic TZ as it is listed in this table. And then we are going to have wider TZ for the size. Because previously we had this one, the TZ for positioning was 1, and TZ for the size was plus minus 0.3. But whenever we are going to have 0 MMC, this TZ for the size will be wider, and we are going to have this dynamic TZ based on hole diameter. Case number 3, we are going to have 2 independent, let's say FCF, feature control frame. Whenever we are going to have these 2 independent positioning, we are going to refine it. First, we are going to refine it with 1 and then a little bit larger TZ. Case number 4 and 3, they are the same. We are going to have this 0 MMC, but we are going to have larger TZ for the size here. In a set of 7.7 and 10.3, we are going to have 8 and 10. For case number 5 and 6, we are going to have composite FCF. For 5 and 6, whenever we are going to have 0 MMC, we can see we are going to have wider TZ for the size. Whenever we are going to have this 1 as a TZ, as we can see in this second line for this composite positioning, we are going to have this, let's say, a smaller TZ plus minus 0.3. For now, I would like to compare case number 3 and 5. As we know, in case number 3, we are going to refine the TZ. We are going to take care about location and orientation. But whenever we are going to have this composite positioning control in second line, we are going to take care about the orientation, not location. What does it mean? It means the center of this pattern may not be at the center of this axis. It may not be located at datum axis B. As we can see in this figure, at top right, we can see here, we are going to have 2 TZ. Here we have TZ equal to 2, and we are going to have TZ equal to 1 here in second line. This whole pattern can be located in a way the center of that pattern may not be at the center as it is defined for B, because here we don't have B here in second line. We can see it should be perpendicular to A. We don't have B here anymore. For positioning, as we know, the distance from the hole should be PCD divided by 2 respect to, let's say, axis B. And in order to take about the orientation, the distance between 2 holes should be this 45 degrees. That's why we are going to have this basic dimension here. Whenever we are going to have this composite FCF, we don't care about location. We take care about the orientation. That's why this center may not be on axis B. That is the difference between case number 5 and 3. Here in this example, easily we can see we are going to have this composite FCF, we are going to have these 2 independent positioning control. For this, we can see on left-hand side, we are going to have 2 TZ, the small and large one. The small one is highlighted by these red circles here. It is 0.2, and we are going to have 0.8 as this green one. The center of these holes can go up and down, left and right. It means the center of this pattern may not be at the center of that, let's say, that pattern for the green one. It can go up and down, left and right. Just for rotation, we are going to take care about that, not position. But whenever we are going to have 2 independent position control here, we are going to have B here. It means these small red circles can go just left and right. It cannot go up and down because we need to take care about position respect to B. But here, we don't need to take care about position respect to B. We need to take care about orientation, not location here. Whenever we are going to have composite FCF. Let me talk about this because at the beginning I have mentioned this reference axis B is not good. Why it is not good? Because it is short. Here I'm going to highlight this one. Whenever we are going to use gauge in order to fix that component, in order to find the axis of that short cylinder, it is a little bit difficult. That's why whenever it is short cylinder, it is good not to define the axis of that short cylinder as a reference, because it is difficult to have this, let's say, gauge. Here, just I would like to highlight it. In order to find this gauge for that short cylinder, it is difficult. Let's have the axis of long cylinder as a reference axis. Here, in this example, we can see we're going to have one hole here, and it should be perpendicular to, let's say, perpendicular to this A here, and with the distance of this R26 here respect to reference axis B here. And now I will not talk about this number 11, 12, and this positioning here. Let's talk about this number 11 here. We are going to have location orientation form as it is here, LOL, for this surface here as it is highlighted, location orientation form, and the TZ, it is 2, 0.5, and 1. And now I will like to talk about this parallelism and this run out. In this figure, we can see we can use each of them. We can use parallelism and run out. If we are going to use this run out, it means this surface can go in this manner as it is highlighted here. I'm going to show it by mouse. Whenever we are going to have this parallelism, we are going to have the same situation. Personally, I think it is good to use this parallelism, not run out. But both of them is going to work here. And for, let's say, this number 12, we have run out and perpendicularity. Again, we are going to implement this one. Personally, again, I think it is good to implement this perpendicularity in order to control this outer surface of this cylinder, as we can see here in this figure. But we can see if we can use this, let's say, run out, we are going to control the same, but perpendicularity is much better. Whenever the component is not going to rotate, it is good not to implement run out or total run out. Let us control the direction of that by using this perpendicularity. And here, for inner surface, I'm going to implement positioning. However, we can implement total run out, or let's say run out. But again, it is not going to rotate. This element is not going to rotate. That's why, again, I have this emphasis. Please use positioning control for that. As we have talked previously, whenever we are going to have this position control, it means we are going to control location and orientation. But whenever we are going to have total run out, we are going to control location, orientation, and form. For the size, again, we are going to control the size and form. And if the form is not that much important, let us implement this positioning to control the orientation and location of this surface. Yeah, for now, I would like to close this session. Thank you for today. I hope you enjoyed. See you next time.